Now let's go over what circular queues are, and we will implement some methods listed over here later. But first, let's go over what exactly circular queue is. Circular queue is a linear data structure, so it's like an array that follows the FIFO principle, and this is exactly the same as our queues. And FIFO stands for first in, first out principle, where we think of a line, and let's say that we have 3 people in the line. The first one that's going to go out is the first person, second one is the second, third is going to be the third person. We're not going to be taking out this person out first. They'll be kind of cutting the line. So think of as a simple line at a movie theater. Now, there is a huge difference between a regular queue and a circular queue, and that is that circular queue resolves the limitations of regular queue, which avoids waste of space that occurs in regular queues. And if you remember from our queue implementation from before, you saw that we had empty spaces where we just named it, I think it was null, and we might have an element over here. So even though these 2 spots, so index 0 and 1 is technically empty, we weren't really able to add more elements here because that's just simply a limitations of queue. So in order for us to really add more elements, what we have to do is we have to dequeue this last element so that we have everything set to null. And when this happens, what we did was we reset our queue to an empty regular array so that we can put more elements here later. So circular queue solves this whole problem, which avoids waste of space for our queues. Now, the benefit of circular queue is that we can make use of the spaces in front of the queue. So these spaces over here. In a normal queue, once the queue becomes full, we cannot insert the next element even if there is a space in front of the queue until the queue is reset. And that's what we went over exactly just now. Even though we have a 2 spots depth empty at index 0 and 1, we couldn't put more elements until we were first able to get rid of the last element and reset our queue. So using circular queue, we can use the space to store new values. So it's more efficient in terms of its usage of space. Now, this is going to be methods that we want to implement, and these are going to be our time complexity. And our time complexity is pretty much the same. Access is O of 1, search O of n, insert and deletion is O of 1. And space is also O of n, and that's going to depend on the number of inputs. If you guys find this helpful, make sure you guys like and subscribe. Thanks. Now let's go over our circular queue. And let's say that we have an empty queue over here, and we have a size of, let's say, 5. So size of the queue is 5. We are able to input 5 elements to our queue, and we are of course going to have first and last pointer that points to -1, and technically -1 is over here. So in the beginning, when our queue is empty, our first pointer is over here and last pointer is over here. And let's say that we add bunch of elements to our queue. Well, let's start with the first one. We have 1 element in our queue, and now our first pointer is going to point to element 0, and last is also going to point to that. And let's say we add 1 more element, so that's going to be O1. First is still going to be here, and then last is going to be here. And let's add in a bunch of other elements. So first is obviously going to be this one, and this is going to be last. Now let's dequeue some elements. So let's remove some elements, and just like queues, when we dequeue an element, it's always going to be from the beginning of the array. So let's say that we dequeue element 0. So that's going to make our array look like null here. 1, 2, 3, and 4. And first is going to point to this one, and last is still going to point to this one. Let's say that we want to add an element. Well, before, when we had a regular queue, we couldn't technically add 1 more element because this was seen as a full queue, because in order for us to add more element, we had to reset the whole thing, even though we knew that index 0 is technically empty. But circular queue solves that problem, and we are actually able to add an element to this index. And let's say that we want to add in the number 5. So if you were to do that, it would be something like this array, where last would point to this and first would point to this. And this whole thing was not possible in our regular queues. In order for us to add this element, we had to dequeue our 1, 2, 3, and 4, and then reset our array to an empty array, and then add in the number 5. But circular queue just solves that problem, and this is what makes circular queue more efficient in terms of its usage of space, because we have no wasted space. As long as we have an empty spot, we are able to add our element to our queue. Now let's implement our circular queue. And for this, I have my pseudocodes. I pre-wrote my methods. You just have to code in the solutions. And if you remember from our array implementation, our stack implementation, and implementation of our queues, we used classes and we used just regular constructor function to add in our methods. And you probably saw that it's really a lot of typing to keep typing. So circular queue prototype our method, circular queue prototype dequeue. And this one is a simplified version. So we just type circular queue.prototype once, just kind of add in our methods. But still, even if this is shorter than our solution before, it's still a lot more typing compared to using classes, because if you were to use classes, we can just do enqueue parentheses and curly braces and just type in our code. But this one is just a different way to add in our methods, but it's doing the same thing. This is exactly the same as doing circular queue.prototype enqueue, circular queue.prototype dequeue. It's just a little bit shorter. Now let's go to our constructor function where we create circular queue, and this is going to have 4 properties. The first one is going to be the store, where we store our data, and second one is going to be the size, and size is going to be passed in, and we make first and last pointer that points to obviously first and last element in the store. So this is going to be an index, and we gave an extra property, and this is just going to track the length of our current queue. So now let's try implementing that. This is going to be this.store is equal to an empty array. Next is size, and size is going to equal to whatever we pass in. Next is this dot first. We set this equal to -1. Next is this dot last, and this is also going to be set to -1. And lastly, this is going to be keeping track of the length of the queue. So that looks good, and let's just check if this worked well. Now let's instantiate a new circular queue, and we do that by const, and I'll just call it CQ for circular queue. We use the new keyword, and it's going to be circular queue, and we have to pass in a size, and let's pass in 3. And let's just console log our circular queue, and let's just console log our methods. So that's going to be circular queue.prototype. Okay. Now you can see that we have our initial state. So empty store size is 3, first and last temporarily points to -1, and our length of the queue is 3. And here we have our methods. So enqueue, dequeue, front, rear, isEmpty, isFull is there, but we haven't obviously implemented them yet. Now let's first implement our isEmpty method. And I want to implement this first because I want to use it in my enqueue and dequeue method. And if we were to use just this method to check if the queue is empty, it reads much better in my opinion. So here we just simply have to return a Boolean value, and if it's empty, it's going to return true. If not, it's going to return false. So simply what we do is we use the logical operator not and pass in our length, this dot length. So if our length is 0, that means that our queue is empty. So this is going to evaluate to 0, and 0 is false in JavaScript. And if we were to use logical operator not, this is going to return true when our length is 0. So let's test our code. So that's going to be console log is empty. That should return true, and we have to do circular queue dot. And here you can see that it's empty and it's working well. Let's implement our isFull method, and this one checks if our queue is full. So when our queue is full, that means that our length of queue is going to be equal to the size of the queue. So we just simply return this dot size is equal to this dot length. Can't really test our code, but let's see if this returns false because we have nothing in our queue as of now. And you can see that it's returning false because our queue is currently empty. Now let's implement our Enqueue method. So for Enqueue, we add an element to the end of the queue, and it's going to take a parameter value, and that's the value that you want to add. And we check, well, is our queue full? If it is, we just want to return, because if our queue is full, we can't put in more elements. And we check, well, is our queue empty? Well, if it's empty, we want to set the pointer to 0. And next, this is probably the hardest part of circular queue. And this is what pretty much defines what circular queue is compared to queue. So we set the pointer, the last pointer, to this last +1 mod the size of the queue. And this is going to be actually doing the same thing for our dequeue method, but for the first pointer. And let's save this one for later. And let's go over how this works. And next, we want to store our value to the correct index, and we increment the size or length by 1. So first thing is I want to use isFull method, and that's why we implemented that earlier. You don't have to if you don't want to, but I think this reads better. So if it's full, I just want to return. And now we need to check if it's empty. So is it empty? If it's empty, what I want to do is I want to set my first pointer to the correct one. Okay, that looks good. And now I need to set my last pointer. So last pointer is going to be this dot last is equal to this dot last +1, and we mod it by the size of our queue. Okay, that looks good. And we will go over this line later and see how that works. Now we need to store our element to the correct index, which is represented by the last index, and we set this equal to the value that we were given. And lastly, we want to increment our length of the current queue by 1. Okay, now let's go down and check if this worked. Now let's add some elements. So it'll be CQ in queue, and let's add 1. And let's just console log our queue. You can see that we were able to add one element. So we have one element, size is 3. First and last points to index of 0 because right now we only have one item and length is 1. So let's add 2 and let's add 3. And you can see that we have 3 elements, size is 3. First one still points to the first element. Last one points to index of 2, length is 3. What if we were to add one more element? You can see that it's not doing anything because our queue is full. And let's go back up and check how this line works. Now let's console log this dot last. So we can see that our values are 0, 1, and 2. And this is exactly the index of our elements that's going to be added. So for the first iteration, it's going to be 0. And how did it come to that this is 0? So at first, our last pointer is at -1. And if you were to add 1 to that, it would be 0, right? And if you were to do 0 mod the size, which is 3, that's still 0. Well, our last pointer is going to be 0 now, and we add 1 to that, and 1 mod 3 is still 1. And then next, our last pointer is at index 1, and index 1 plus 1 mod 3 is 2. So this is how the elements are going to be added. So it's going to be continually moving at a different index, and we mod it by the size that's given. And I think this might be more clear to you when we implement our dequeue method, so stay for that. Now let's go over our dequeue method where we delete the element at the beginning of the array. So first, what we have to do is we check, well, is it empty? If it's empty, we return, because if it's empty, there's nothing to delete, right? And then next we check, well, we first have to store the element that we are going to remove to a variable because we want to return that later. And then next we overwrite the element that we deleted with the value null, and you can just overwrite it with undefined if you like. And next we set our first pointer to the next element, which is going to be represented by this dot first +1 mod the size. And we will go over this later. I think it can be a little bit trickier to understand how this thing works. And then next we decrement the length by 1 because we deleted a element. And then next, if the queue is empty, meaning if we just have everything full of just null values, we want to reset our values. And finally, we want to return the removed element. Now let's code our solution. So first, I want to check if it's empty. And I will do that by using isEmpty method. And I want to return that over here. And next, I want to store my dequeued element, and I'll call it dequeue. And this is going to be at this.store at this.first, because we are always removing the first element. That's the definition of what dequeue is. And I should have a E here. Okay, that looks good. And then next, I want to overwrite the element that was deleted, or we are going to delete, with null. And then next, we want to reset our first pointer to point to the next element. So it's going to be this dot first plus 1, and we mod it by the size. Okay, that looks good. And next, we want to decrement the length by 1 because we removed an element. And finally, we want to return our dequeued element. But before that, we forgot one thing. We have to check if it's empty. If it's empty, we want to reset. Now, if this dot is empty, we want to reset our store. This dot store is going to be an empty array. This dot first is going to be -1, and this dot last is also going to be -1. And we don't have to change this dot size and this dot length, because if this evaluates the truth, that means our length is 0, so we don't really have to change that. And size is going to be a passed-in value, so we don't have to change that also. Now let's try going over our code and see if this worked. So we have our enqueues here where we add elements. Let's comment this one out, and let's do console log circular queue, so CQ and dequeue, and that should return 1. So that should return 1, and you can see that we removed the first element and we overrode it with null. And our first pointer is pointing at element at index 1, last one is still pointing at 3, and our length decreased by 1. Now let's try adding one more element. What we would expect. Well, before, when we just implemented regular queue, we couldn't add the element, because even though this spot or element at index 0 is now empty, we couldn't add a element to that spot in our regular queue, and that was the limitation of our regular queue. But let's see if circular queue is able to resolve that. So enqueue, and let's add in 4. So now you can see that our 4 is successfully added in. So our first element is index 2 or index 1, which is element 2, and then last one is at index 0. So you might be wondering, this number 4 is at the beginning of the array, and how is that the last element? Well, think about our circular queue and the name why it's circular queue. So at first, when we didn't dequeue, so let's uncomment this, it was 1, 2, 3, right? So it goes in right direction. And when we dequeued element, we removed the first one. But when we add it in, we come back over here to the front of the queue and then add that element. But although this 4 is at the beginning of the array or our queue, its order is not the first one. Order goes 1, 2, 3, and then we come back, and this is the 4th element, and it's going to be 5 and 6 and so on and so forth. So we just keep coming back to in this circular motion. So that's why our last element is represented by index 0, which is 4. Now let's try removing our elements. So that should now return 2. Now that should return 3. And let's just try to add one more element. So that's going to be 5. And you can see that is inserting at the correct spot. But now our first element is 4. And now last element is 6. So let's try removing all our elements. So that's removing the element 4. And now you can see that it's removing the element 5. And we reset it all of our elements or properties to its initial state, because now we know that all the elements are gone. Now let's go back up and see how this line worked. So let's console log our property first, this dot first. You can see that first index is going in a circle. It's not showing 0 because we incremented here. So if you were to just console log over here, you can see that it's going 1, 0, 1, 2, 0, 1, 2. So it keeps going around in a circular motion. And this is what exactly doing. And this is the same logic for our Enqueue method. It's just that for it's the last pointer. And our last pointer again is going 0, 1, 2, 0, 1, 2. And it's going to do that forever as long as we enqueue and dequeue more elements. So this line is the pretty much major factor that defines how dequeues work. But other than that, you probably notice that almost everything is the same. The logic is the same. It's just that we are just keep going around in circular queue, adding more elements if possible. Now let's implement our front method where we just simply return the value of the front element, and that's going to be really simple. So we just return this dot store at index. It should be this dot first because we want the first one, and that's it. Let's try our code. Let's go back here. I'm going to uncomment the, and let's do console log circular queue, and it should be front. That should get 1 because 1 is the first element, and if you were to dequeue, that will give us 2, and so on and so forth. Now let's implement our last method, which is going to be rear, and just like front, this is just going to return a value, and this time it's going to be the element at the end of the queue, so rear of the queue. So like before, it's going to be return this dot store, and we just simply want to return the last element, which is represented by the last pointer. And let's test this code, and let's do console log circular queue rear, and that should return us 3. And you can see that it's returning 3 because that's the last element, and even though we dequeue an element, that's still going to return 3 because that's still our last element. If you guys find this helpful, make sure you guys like and subscribe. Thanks.